is Algebra 1, Spring Test number 5, Study Guide. Number 1 says to solve for x. 3 times x minus 1 minus 4x is greater than or equal to negative 2. Before you try to bring anything across the equal sign, you have to simplify, not the equal sign, the inequality in this case. You have to simplify each side. Order of operations tells us we need to do multiplication before we do minus 4x. So we need to distribute 3 times x n times negative 1. 3 times x is 3x. 3 times negative 1 is minus 3. We still have negative 4x there. We still have an inequality sign that says greater than or equal to, and it's greater than or equal to negative 2. Again, before we try to bring anything across, we need to simplify the left side. There's a right side and a left side of this inequality just like this. Combine 3x and negative 4x. 3 minus 4 is negative 1x. So if you need to write in a negative 1x where you can see it, there's nothing wrong with doing that until it's time to simplify the final answer. Negative 1x is still minus 3, and it's greater than or equal to negative 2. Nothing changed in that regard. Now, you can't put negative 1x and negative 3 together since they're not like terms. Now it's time to start undoing things. Undo the fact that it says minus 3 by adding 3. Remember what you do to one side of a problem or one side of the inequality here, you do to the other side. You add 3 here. Negative 2 plus 3 is positive 1. And you still have negative 1x on the left. Every step you undo stuff in an inequality, ask yourself, do I reverse the symbol or do I leave it as it is? Right here, all we did was add 3, so we leave the symbol as it is. So it's still greater than or equal to. But it's not what x is equal to yet. In order to get x by itself, we need to undo the fact that this says negative 1 times x. You do that by dividing by negative 1. When you do it to one side, do it to the other side. 1 divided by negative 1 is going to be negative 1. X is going to be by itself. Now, one more time, you ask yourself, do I need to reverse the symbol or leave it? In this case, we divided both sides by a negative number. Anytime you divide or multiply both sides by a negative number, you reverse the symbol. Greater than or equal to reverses to become less than or equal. X is less than or equal to negative 1. Number 2 test says solve the inequality. We'll go a little bit quicker this time. Undo the fact that it says minus 6 up front by adding 6. If you do it there, do it here. 0 plus 6 is 6. So you have negative 3x on the left. All we did was add 6 to both sides, so we leave our inequality like that. Undo the fact that it says multiply by negative 3. Do it here, divide by negative 3, and here, divide by negative 3. 6 divided by negative 3 is negative 2 since they're opposite signs. Negative 3 divided by negative 3 will cancel out and leave you with x. When you divide by negative numbers on both sides, again, just like on number 1, you reverse the inequality sign to say greater than or equal to. X is greater than or equal to negative 2. Number 3, what are the solutions of 9x plus 28 is greater than 4x minus 17? It's just telling you to solve it is all it means by what are the solutions. You have a left side and a right side. Again, you have variables on both sides. You want to collect them on one side. Remember, you can collect them on the larger variable side, and typically with equations, that's what we like to do. With inequalities, however, we like to bring them to the left side simply to graph them easier. It's not wrong to bring them to the right side. It's just easier to graph them if the variable's listed first. So we want to bring 4x over to the left. It's positive 4x, so when we collect them on the left, we subtract 4x. In order to undo that, you do that. When you do it to one side, you have to subtract 4x on the other side. 9x minus 4x is 5x. You still have plus 28 there, and you still have negative 17 on the other side. Ask yourself, do I have to reverse the symbol or leave it alone? Remember, anytime you multiply or divide an inequality on both sides by a negative, you reverse the symbol. In this case, all we did was subtracted 4x, so leave the symbol alone. Since we brought our x's to the left side, our variables to the left side, we want to bring our constant terms to the right side. It says positive 28. You undo positive 28 by subtracting 28. When you do it to the left side, do the same thing to the right side. These are the same sign, both of them are negative, so add up the numbers 17 and 28. 7 and 8 is 15. Carry your 1. 2 plus 1 plus 1 is 45. And keep that negative that they both had in common. So now you have 5x on the left. We subtracted on both sides, but we did not multiply or divide by a negative number, so we leave our symbol as greater than. and we want to get x by itself. So undo the fact that it says 5 times x by dividing by 5. You do it to the left, do it to the right. Negative 45 divided by 5 is opposite signs is going to be negative 9. So you have x, and then one more time, ask yourself, do I need to reverse the symbol? We divided right here by both sides by 5, but it was by a positive number. So your symbol stays just like it is. X is greater than 9. Number 4, solve the compound inequality and graph the solutions. So now instead of having a right and a left side, now we got a left side, a right side, and a middle. Remember, when we do to one portion, we have to do to all 3 portions. In order to undo plus 2 in the middle, because we want to get x by itself, we subtract 2. If you do it to the middle, you subtract 2 on the left, and you subtract 2 on the right. This will cancel out. Negative 9 minus 2 is negative 11, and 14 minus 2 is 12. You have to ask yourself, do I need to reverse the inequalities? All we did was subtract 2. We did not multiply or divide by a negative number, so the inequalities will stay just like they are. Negative 11 is less than x and less than 12. It tells you also to graph the solution. So when you're graphing an inequality, if you need to draw your own number line, just include the numbers that are relevant. In this case, negative 11 and 12. Because there's always an infinite amount of space between the two. Just make sure you have them on the correct side. You don't want 12 on the left side of negative 11. Graph this compound inequality as 2 separate inequalities. The easy one to graph, as I keep mentioning, is this one here. This one here, the one that you can read it with the variable first. It says x is less than 12. So less than is an open bubble. You don't color it in because it's not or equal to, and less than is everything this direction. The other one is harder to see, this one, only because the variable comes second. So if you need to rewrite it to where the variable's first just to make graphing easier, change the position, x and negative 11. Remember, the big mouth in this case right here again is eating the x. So make sure when you change your position, the symbol goes with it. X is greater than negative 11. Again, an open bubble, and greater than is everything this direction. There's the graph that goes along with it. Number 5 says write a compound inequality that represents the following phrase and then graph the solutions. All real numbers that are between negative 3 and 6. So 2 separate inequalities that go together. This word between, anytime you see this is an and inequality. So it's saying all real numbers that are between negative 3 and 6. So if you look at it as a graph, it might help you to look at it as a graph first and kind of do this out of order. So if we say from negative 3 to 6, we know that it's all the numbers between negative 3 and 6. Okay. So it's not counting the other ones that go with it. So since we have these inequalities that look like this, we have this overlapping area here. So it's going to be an and inequality. So the first one is going to be x is greater than negative 3. The other one's going to be x is less than 6. Since it's an and inequality, we're going to put them together. The x is going to be in the middle, so we use this one. And it goes the same direction as negative 3. It goes the same direction as less than 6. So x is less than, in that case, negative 3. So here's your compound inequality. Negative 3 is less than x and less than 6. 6 says, in a community garden shown, you want to plant a fence in a vegetable garden that is adjacent to your friend's garden. You have at most 40 feet of fence, and the fence must surround all 4 sides of your garden. What are the possible lengths of the garden? Well, it's right next to your friends. If this is 7 feet here, then that means yours is going to be 7 feet for both of those. So you have 7 feet and 7 feet for this one. So together, that's 14 feet. So if you take 40 feet of fence total and you subtract 14 from it, that means that you have 26 feet of fence left over. You need another amount there and there on the fence. So you take that 26 and divide it by 2, it has to be the same amount. And each of those sides can only be 13 feet. So 26 divided by 2 is 13 feet. The other possible lengths, it says what are the possible lengths, would be anything below 13 feet, 13 feet or below. Anything larger than 13 feet and you won't have enough fence out of 40. So if you'd write this in an inequality form, x would have to be less than or equal to 13 feet. Anything longer than that, and you wouldn't have enough fencing material to do it. Solve the inequality and check your solution. Okay, we only have a left and a right side here. You want to get x by itself. Let's move our x to this side, just to where it'll be easier to graph it and it'll be easier to understand it. If you move 4x over from the left to the right, it's positive 4x, you subtract it. When you subtract the right, you subtract the left. Negative 4x you still have there. You still have positive 5 there. That wasn't moved. And you still have negative 11 on the right. All we did was subtract 4x on both sides, so we do not reverse the inequality. The next thing you do, undo plus 5 by subtracting it. Minus 5 here and here. Negative 11 minus 5 is negative 16. So you have negative 4x and negative 16. Again, all we did was subtract there, so leave the symbol just like it is. Undo negative 4 times x by dividing by negative 4. You do it there, do it here. Negative divided by negative is a positive. 16 divided by 4 is 4. And in this case, we did divide by a negative number on both sides by negative 4. So we will reverse the symbol. Less than will become greater than. So x is greater than 4. Where it says to check your solution here, plug in a number that's greater than 4 and see if you get a true statement. So the original equation says 5 is less than negative 11 plus 4 times x. That x value we'll plug in is any number that's greater than 4. So let's say the number 5. 4 times 5 is 20. Negative 11 plus 20. 5 is less than that. So negative 11 plus 20, when we put those two together, is the number 9. 5 is less than 9. That's a true statement. Notice the big mouth is eating the bigger number. Solve the inequality, and again, check your solutions. Now the inequality, or the z value, it's not x this time, they just give you z. You treat it the same way. It's on the left side already. Subtract 2 on both sides. Go a little bit quicker with this one. 22 minus 2 is 20. You have 5z. All we did was subtract, so we leave the inequality like it is. Divide by 5 to get rid of 5 times something. Do it here as well. 20 divided by 5 is 4. We divided both sides, but it was just by a positive number, so we'll leave the symbol just like it is. Z is less than 4. Again, check your solution. If you plug into the original equation, 5 times z, something less than the number 4. So let's say 3. 5 times 3 plus 2 is less than 22. 5 times 3, we know together, is 15. And 15 plus 2 is less than 22. 17, this is a true statement because the big mouth is eating the bigger number. Number 9 says solve for x, check your solution. Again, variables are now on both sides. We want to bring our variables to the left side, so move 4x over by subtracting it. If you subtract 4x here, you have to do the same on the other side. That leaves you with 1x there plus 1. All we did was subtract, so you don't need to reverse the inequality symbol. Undo plus 1 by subtracting it on both sides. X is less than negative 3 minus 1 is negative 4. X is less than negative 4. When you check that solution, 5 times x, 5 times something less than negative 4, so let's say negative 5, plus 1. I'm going to have to move this one over a little bit. So 5 times negative 5 plus 1 is less than 4 times that same negative 5 minus 3. And I know I'm jumbled up here, but just for the sake of space, 5 times negative 5 is negative 25. 5 plus 1. 4 times negative 5 is negative 20 minus 3. This together is negative 24. It says this is less than negative 20 minus 3 is negative 23. That's a true statement. The big mouth is eating the big number. 10 says your cell phone plan costs $24.99 per month plus 15 cents for each text message you send or receive. You have at most $30 to spend on your cell phone bill. What's the maximum number of text messages that you can send or receive next month? It costs $24.99. That's how much it costs, no matter if you send 0 text messages or an infinite amount. plus they charge you 15 cents per text. So plus 15 cents per text, which is an unknown amount. So it'll be times X. And then you have the number $30 that you can spend. So 24.99 plus 15 times X. That number, this whole side here together, when you put it together, has to be less than or equal to $30 because you can't spend $31. So now the inequality so now your inequality is set up. Undo your order of operations. So undo positive 24.99 by subtracting it on the left. Do the same here. Subtract 24.99. Notice you have to make sure the decimals are lined up when you subtract. So a dollar minus 99 cents is 1 cent. And we have to borrow from this. So we're going all the way down. 10 minus 9 is, let me redo this, excuse me. Let's go all the way through it to where we don't make any mistakes. Borrow from this 3. The borrow from this one makes it 9. Borrow from this one makes it 9. Now we in good shape. 10 minus 9 is 1. 9 minus 9 is 0. 9 minus 4 is 5. And 2 minus 2 is 0. So $5.01 is left over. This is canceled out. 15 cents times X is still there. Then you want to get X by itself. Divide by 15 cents. When you do it here, do it here. How many times does 15 cents go into $5.01? And X's value has to be less than or equal to 33.4. And in this case, it's 33.4 text messages. So if you send 34 messages, you will go over your $30 budget. So you can't spend or you can't send any more. Your maximum number of text messages is 33. Number 11 says solve it and graph it. We have two sides. We got variables on both sides. Bring 2x over by subtracting 2x on both sides. Minus 2x is x plus 2, which is less than negative 3. Get rid of plus 2 by subtracting it on both sides. X is less than negative 5. Graph the solution. It's in one variable. We'll look at two variables starting next week. Um, Include negative 5. Just include 0 with it. It says less than negative 5, so it's an open bubble and everything to the left. Solve the inequality and graph the solutions on a number line. So the same thing. Before we have to move anything over, we have to distribute 7 times x and 7 times negative 6, negative 42. So we have 7x minus 7 is less than 7x minus 42. Now we have our variables. If you look at it, they're going to cancel out right here. When we try to bring 7x over to the left side by subtracting it since it's positive, when we do it here, 7x minus 7x is 0 x's. So look and see what we have now. If this cancels out and this cancels out, we're left with something that says negative 7 still is less than negative 42. Evaluate if this is a true statement or not. Okay? When we evaluate this one, it is not a true statement because negative 7 is not less than negative 42. Negative 7 is actually the bigger number in this case. So this, even though it tells you to graph the solution, you cannot because there is no solution to this inequality. No slow. No solution. 13, solve the inequality. Solving this one says for you, if possible, 3 times 4. 3 times 4 is 12. 3 times x is positive or plus 3x. Greater than or equal to 15 minus 2x. Again, you want to, with inequalities, bring your x's or your variables to the left. Subtract, it says minus 2x already. Undo that by adding 2x. You do it there, do it here. 3x plus 2x is 5x, and it's positive. So you have 12 plus that is greater than or equal to 15. Undo 12 or bring it over to the other side. It's positive, so subtract 12. When you do it there, do it here. 15 minus 12 is 3. So we have 5x is greater than that. Undo 5 times something by dividing by 5. When you do it there, do it here. And x is greater than 3 over 5. So x is greater than 3/5. We did not have to reverse any symbols because we did not multiply or divide by a negative number on both sides. Solve the inequality, graph the solution. So this is a compound one with or in the middle. Solve them as two separate ones. Add 1 to both sides. 3t is less than negative 12. Divide by 3 on both sides. T is less than negative 4. You don't reverse it because you only divide it by a positive number. Subtract 4 on both sides to cancel it out. So 2t is greater than 4. Divide by 2 on both sides. T is greater than 2. This is an OR inequality, so it's together by saying t is less than 4, negative 4, or t is greater than 2. 15 says solve the inequality, check your solutions. Again, there's a y treated just like x, variables are variables. Subtract 5 on both sides. 4y is less than or equal to 17 minus 5 is 12. Get rid of 4 times something by dividing by 4. Y is less than or equal to 3. So check this to see if it's correct. We didn't have to reverse any symbols by plugging in a number less than 3. 4 times y plus 5 is less than or equal to 17. A number less than 3, let's say 2. 4 times 2 is 8. Plus 5 is less than or equal to 17. This together is 13. This is a true statement. The big mouth is eating the big number. Now it is. 16, solve the inequality. 3 times x, distribute 3x. 3 times negative 8 minus 24 plus 4x is greater than or equal to negative 3. Before you can bring anything across, remember you have to simplify one side. 3x and plus 4x, 7x minus 24 is greater than or equal to negative 3. Undo minus 24 on both sides by adding 24. When you do it there, do it here. 7x is greater than or equal to 21. Divide by 7 on both sides. X is greater than or equal to 3. Solve the compound inequality and graph the solution. So you have a compound one now. You got a left side, a right side, and a middle. Undo minus 4 by adding 4. Do it here and here. You have to do it to all 3 sections. This one cancels and leaves you with 5p. We're trying to get p all by itself. This 1 plus 4 is 5. 31 plus 4 is 35. All we did was added 4, so we leave all of the inequality symbols, not that one. We leave all of them just like they were. This one's less than, this one is less than or equal to 35. Get p by itself by dividing by 5. Do it here and here. 5 divided by 5 is 1. 5 divided by 5 cancels and leaves you with p. 35 divided by 5 is 7. So all we did was divide by 5. Leave your symbols looking just like they were. That one's less than, this one's less than, or equal to. Graphing the solutions, remember when you graph these, you're graphing them on one number line. So you only need to show the numbers 1 and 7. Graph the first one. Graph the one you can see. Less than or equal to 7. That means a colored in bubble, everything that way. The other one's backwards. Remember, read it from the variable if you can. This one here, this one. But if you need to, rewrite it as P and 1, the big mouth eating the P. Open bubble, since it's only or greater than, not or equal to, and everything that way. That's how your graph should look for number 17. 18 says write the inequality in interval notation, then graph the interval. Okay, interval notation, all it is setting the boundaries. It's a left boundary and a right boundary. So this one right here would be as an ordered pair. It says less than negative 7. So if you think of that as a graph, this is an OR inequality, so we'll graph them first to where we can see them. We need negative 7 and we need 6. This one, the red one as I have it, will say less than or equal to negative 7. The blue one, greater than 6, is an open bubble and everything that way. So when we do this one, we need to set a right and a left boundary. For the blue one, the left boundary is the number 6. The right boundary, since it goes on forever, it's infinity that way. That's interval notation is all it is. The other one, its right boundary is negative 7. It's saying everything less than that, so its left boundary is negative infinity. That's all intervals. So this is your compound inequality in interval form. Something very, very simple. Solve this inequality. Negative 3 times x, negative 3x, negative 3 times 3 minus 9 plus 6x is less than negative 6. Combine your like terms, negative 3x and positive 6x. 3x minus 9 is less than negative 6. Get x by itself by adding 9 to both sides. You don't reverse the symbol because all you did was add 9. So you have 3x is less than 3. Divide by 3. Do it here. 3 divided by 3 is 1. X is less than 1. Again, solve for x. Very similar problem. 3 times x is 3x. 3 times negative 3 minus 9 minus 4x. It's greater than or equal to negative 3. Again, now since we want to simplify it by putting those together, 3x minus 4x is negative 1x. Minus 9 is greater than or equal to negative 3. Now it's time to start undoing. We want to undo the fact that it says minus 9 by adding 9 there and here. Negative 1x is greater than or equal to negative 3 plus 9 is positive 6. We do not reverse the symbol because all you do is add 9. On this part, you divide by negative 1. When you do the same to the other side, a positive divided by negative gives us a negative 6. You have x and negative 6. Since we divided by negative this time, you undo the fact that it says, or you reverse the fact that it says greater than or equal to, and make it say less than or equal to. X is less than or equal to negative 6.